Hello students, let us take a look at question number 7 of exercise 8.1 of chapter quadrilaterals. This is on page number 146 of your textbooks. We've been given that quadrilateral ABCD is a rhombus and we need to prove that diagonal AC bisects angle A as well as C. That means we need to prove that 1 is equal to 4 and 2 is equal to 3. And similarly, we need to prove that BD is going to bisect angle B as well as angle D. I haven't marked 5, 6, 7, 8 over here because for the moment we are going to prove that angles A and C are getting bisected by AC. So let us go ahead and prove this. So first of all, since quadrilateral ABCD is a rhombus, we have all the sides equal, that is AB is equal to BC is equal to CD is equal to AD. So if you take a look at your triangle ADC, what do you have? You have AD is equal to DC. So for this triangle, the two sides are equal, therefore the angles opposite, that is angle 2 and angle 1 are going to be equal to each other. So let us write this down. I will say proof. In triangle ADC, AD is equal to DC. Why? Because sides of a rhombus. Right? Therefore, what can I say? That angle 2 is equal to angle 1. So, this is for triangle ADC, 2 is equal to 1, and the reason here will be isosceles triangle theorem. Let's mark this as 1. Similarly, in your triangle ABC now, you have AB is equal to BC by the same reason, sides of a rhombus. Let's write this down. In triangle ABC, AB is equal to BC, I'll say sides of a rhombus. Therefore, according to isosceles triangle theorem, we have the opposite angles equal. So, the angles opposite AB and BC, which is angle 3 is equal to angle 4, right? And I'll say isosceles triangle theorem. Let's mark this as 2. But since a rhombus is a parallelogram, we have parallel sides. Let's take a look at the parallel sides AD and BC. If you take a look at the parallel sides AD and BC and AC as my transversal, I have 1 is equal to 3 and so 1 is equal to 3 and 1 is equal to 3. Let's write this down. Now, AD is parallel to BC, opposite sides of rhombus. See, a rhombus is a parallelogram, therefore the opposite sides are always going to be parallel, correct? Therefore, now since AD is parallel to BC, what can I say? That angle 1 is equal to angle 3 to the through the alternate angle theorem, interior alternate angle theorem. So, 1 is equal to 3 and I will say alternate angle theorem. Let's mark this as 3. So, what do you, if you take a look at equation 1 and equation 3, what do you get? 2 is equal to 3, correct? Therefore, 2 is equal to 3 from 1 and 3. And if you take a look at 2 and 4, you get 1 is equal to 4. You will say from 2 and 3. So, doesn't this mean that 2 is equal to 3? That means C is getting bisected by AC, and when I say 1 is equal to 4, A is getting bisected by AC, correct? So, if you mark these two as a big Roman number 1, you can say from 1 we can conclude that AC bisects angle A and angle C. So, your first two paths are proved. So I'll say from big Roman number 1. Big Roman number 1 consists of these two equations. I'll say AC or diagonal AC bisects angle A and C. Okay. Similarly now, if you noticed, we took these two triangles here, right? ADC and ABC. Similarly, you can prove that BD bisects angle B and angle D by taking these two triangles. Let me show these to you. We are going to take these two triangles because we are going to consider your diagonal BD. Since we had to prove something for diagonal AC, I took the AC as my base. Now I need to prove two triangles getting bisected by using BD as my diagonal. So I am going to take BD as my base of the triangles. So similarly, you can take these two triangles and prove that this here ADB is equal to CDB by marking it as 5, 6, 7 and 8. Suppose let us say I mark this as 5, 6, 7 and 8. Similarly, you can prove that 5 is equal to 6 and 7 is equal to 8, and therefore that BD bisects angle B and D. So I'll say similarly, using triangles DCB and triangle BDA or ABD, parallel lines so we took initially parallel lines AD and BC, so we are going to take the parallel lines DC and AB, DC and AB, and transversal BD. We can prove that BD bisects angles B and D, right. So where are you going to use your triangles DCB and ABD? In this part, right. So this will be these two parts, these two parts, and then you are going to take your parallel lines DC and AB over here with your transversal BD. So I haven't mentioned the transversal here, let me just write the transversal. Our transversal here was AC. So here you will take parallel lines DC and AB and your transversal BD, and then you are going to prove the respective angles equal. Then using the equations accordingly, you are going to prove that angle B and angle D are getting bisected by your diagonal BD. So this was about question number 7. We will take a look at the remaining questions in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.